Good afternoon, everyone, and welcome to the second in BSI's sessions on cryptographic modules. Those of you who joined us before in Barcelona, right back, seems like months ago, back in March, we introduced the subject and started to explore how a common approach to cryptographic module certification might have some potential benefits and what some of the critical things that were needed. And today we're going to take that discussion further forward. So those of you joining us remotely, you are on mute, but feel free to question through the Q&A and we will try to cover as many of those questions as we can. For those of you who might want to enter questions in Mandarin, we might not be able to answer them live at the show, but we will then take note of that and respond back to you afterwards. And we are being recorded, quite obviously, as well. So an interesting mixture today, a hybrid event. We had hoped to have more actually here in Singapore, but unfortunately with the situation in China at the time still being quite unpredictable, we went for a hybrid option. So it's still great to see the flexibility in hybrid really being of use. So the agenda for today, I'm going to start off with an introduction and a background to why we're here in Singapore, and why we're here at all to discuss the subject. We'll then have some input on the general market perspectives with a guest speaker, Dr. Pali Sirdhar from Entrust. And then my colleague Miguel Bagnon, who is the convener of the working group for the standard which we'll be discussing today, will give us an update on the latest on the standard as well. And then we'll get to the heart of this discussion today, which will be a panel discussion looking at how to build trust in a common approach here, in particular, how to do so while addressing national requirements, which we understand is a real critical part of making this a success. There'll then be time for some Q&A as well. And very importantly, at the end, not just a summary, but we'll look at next steps, actually progressing and moving forward. So start off with an introduction and a bit of a background. We start with digital trust. Digital trust is very important to me. It's not just something that's in my job title. It's something I feel really, really strongly is a huge factor in a successful, prosperous, and sustainable future. And that's really true throughout BSI. And I'll come on to more really about BSI and digital trust. But digital trust really is the currency to feed a sustainable future. And what's interesting here is in this statement from Forbes Business Magazine, again, stressing the importance of digital trust. And without it, business is lost. And this is important because this is now a business magazine saying it. This is no longer something that is just the arena of the IT department and the CISO. Digital trust is fundamental to business. And so what does that mean for cryptographic modules? Taking a statement here from the ISO 19790 standard, which we'll be discussing more today. A key point here, that increasing need to use cryptographic mechanisms to protect data against unauthorized exposure or manipulation, entity authentication and non-repudiation. Some really important topics here. The security and reliability of these mechanisms are directly dependent on the cryptographic modules on which they're based. So therefore, cryptographic modules are really sitting there at the heart of digital trust. Bear with me 1 second, I'll just get rid of this little bit of stuff at the top of my screen. Go away. Hide floating controls, that's better. And it's telling me that I'm talking as well, that's very useful. Right, so cryptographic modules, come back to me. Here we go. Are key in providing that data protection, authentication, and non-repudiation. So why is BSI talking about this? What is BSI to digital trust? When it comes to many of the top management systems and best practices for industry, they all started off as British standards. And the one in particular I want to point out today is information security, ISO 27001, started off as a British standard, and certainly now it's one of the most important solutions that we offer to our clients. not just the standard itself, but providing assurance around it. And this very important standard, by the way, has just gone through the most important change in 10 years. And so this is something that every one of you in the room, irrespective of the cryptographic modules side of things, this, in terms of bringing your information security up to speed, is a very important topic. So we might have British in the name, but most of our clients, and indeed our own people, are outside of the UK. So we bring a truly global perspective. Then on this slide here, standards, obviously it's there in the name. We are the national standards body for the UK and a founding member of ISO. But besides that, we provide support around those standards in terms of training, assessment, product testing, certification, as well as consultancy. The most important part of this slide here is that Royal Charter. What that means is we're independent of government, we're independent of shareholders, but we have a mandate to work for the public good. So we are here to convene industry, to support industry, to solve real problems for the public good. And when it comes to digital trust, whether it is artificial intelligence, software trustworthiness, cybersecurity, IoT, testing and training, a whole range of things, this is what we're absolutely at the heart of our business right now. And then in particularly, cryptographic modules. And the main point here is this collaborative approach. Everything at BSI that we do, from the standards that we create to the schemes that we create, all the solutions we deliver it for you, but we also deliver it, create it and shape it with you. Everything that we actually shape here, yes, we convene the experts, but it isn't BSI's opinion. We get the trusted opinion of experts around the world. And this is part of the discussion we're going to be having today. So we've already developed some initial themes around here, and as I've mentioned, the previous event, and now this is the next stage in the ongoing program. So now coming on to cryptographic modules, we'll just refresh a little bit from the last time then as well, just to say really how endemic they are throughout the whole of the ecosystem, from certain hardware modules, and we'll come on to more of that from our guest speaker, and potentially looking at software models as well, or hybrids, right the way through the whole of the ecosystem. Cryptographic modules are an essential component. And right now, with the increase in smart cities, industrial IoT 4.0, very well established, actually looking at 5.0, future mobility, digital healthcare, a very, very important topic to us at the moment. Data matters of it, and becoming more and more critical, both in terms of the value of that data, but also critical to making the whole of the system flow. And with that, safety, security, privacy are obviously key as well. So when it comes to certification of cryptographic modules, the module itself could be a component, a subsystem, or an entire product. And it could be purely software, firmware, or a mixture of hardware, firmware as well. So it's kind of wide range then, both in the size and in the technical scale of the product. And very importantly here, we are seeing thousands of certifications with different requirements from countries around the world, but with one core standard at the heart of it. And right now is a critical time, with more nations deciding their potential policies here, and the demand, as I've just explained, significantly increasing. And when we look at the complexities of the certification, the more that can be done to streamline and provide a common approach will benefit all the stakeholders and the manufacturers in terms of bringing their products to market quicker and knowing what's needed to get them accepted, through to governments having a streamlined process that enables quick and effective selection of a product, provided that the national needs can still be addressed. So when we're looking at creating a certification scheme, we have a standard on which the certification is based. And then the scheme is then the standard and the detailed implementation, the requirements, the evidence needed, the test and assessment levels used to determine conformance. And this is very important. What goes into that, the output from it has to solve a business problem. So you can have a standard and you can create a scheme, but unless it actually solves a problem, it's never going to get anywhere. And with BSI, every scheme we develop it collaboratively with stakeholders. So, 19790 is in development right now, and the input from sessions like this is absolutely critical in help shaping the future schemes and shaping the future of how these products will come to market. So, talking of market, I'm now going to hand over to Pally, who is speaking to us remotely today from the UK. So thanks for joining us bright and early. And I will still continue to drive the slides, but Pally, over to you to talk us through, from a hardware security modules, your perspectives on the markets today and some of the key issues in the future. Pally, over to you.
Thank you, David. And yeah, good morning, good afternoon, and good evening, everyone. Very quick introduction to myself. My name's Pally Serdar, and I'm the Director of Product Security at Entrust. My role entails looking at security and compliance for our cryptographic modules. And today, if we go to the next slide, I'm hoping to draw on some inspiration from Herbert George Wells, who is a great author, futurist, probably known as the Shakespeare of science fiction, where we try and peer into the crystal ball and try and understand what crypto modules look like today and where they might be going in the future. And I'm hoping to draw out some of the challenges that we will face. David's talked very eloquently about the notion of trust, or digital trust, and how that is required all over. Hopefully I can sort of resonate with that, and we can see how that evolves as we move. So today, the theme for today is change. I think we need to understand how we're changing current systems and how those move into the future as well. So on to the next slide. And so a very quick whistle-stop tour of what hardware security modules are, or crypto modules are. And essentially, we can see the word trust come up again. So it's a trusted computer that performs cryptographic operations. And HSMs, or hardware security modules, are often regarded as the gold standard for key management, where you can create and manage keys. There's some very basic functionality, but that's what allows us to drive and protect information security systems. There is also this notion that crypto modules are trusted. And the reason for this is because it's based on hardware or specialist hardware, provides some mechanisms for tamper evidence, so you can't actually fiddle with such devices without them alerting you on it. And the other thing is that you have this capability to produce strong cryptographic keys. So there's a hardware or based random number generator embedded in the system. The modules are supposed to be highly performant. Actually, the end cipher devices, or some of them actually started off as SSL accelerators, and they then moved into this space where they actually were seen to provide fast cryptographic operations, and used in a number of use cases. To access and use an HSM, there are various interfaces. PKCS11, MSCAPI, and JCE, or the Java-based one, are the most common, but you also have native interfaces, and the devices also vary. So you have network connected devices, you have ones that are PCIe embedded into your workstation, and maybe less performant ones that are attached by USB. So that's my very high level slide of what general purpose HSMs look like. Can switch over to the next slide, please, David. David brought up a wonderful slide where you had sort of various aspects of cryptographic module certification, and you showed crypto modules in literally everything from cars to embedded devices to network devices. Here are some of the use cases, but what I wanted to draw out here is actually there's two flavors of hardware security module. Those that are more general purpose, and they're used for encryption, decryption. They use them in your certificate authority to generate certificates. And then there's the ones that are used in the financial industry. And that are used for card processing or card crypto type operations. That's all I'm going to say on the use cases. We can move on to the next slide. So the idea behind our hardware security module is that they protect keys. And in order to do that, there is a intricate hierarchy to protect the keys themselves. And there is also the idea of role separation. So you have administrator activities as well as operator activities. Users develop the applications and create and use application keys, but these are all protected within the boundary of a hardware security module through a couple of means. One could be that you have the actual module key that protects the application key, or a set of logical tokens that can protect operator keys. The interesting thing about that is what they try to avoid is a single point of failure. So you have an idea where a secret split is used to access the actual keys themselves, or the application keys that are being used. And that's one of these approaches to layer in security for the system. The other thing is some or many hardware security systems, the Entrust one, for example, develops an infrastructure or a security world around it within which you can actually operate and use the keys, and it provides a safer ecosystem for working with these keys. So if we move on to the next slide. There is also an idea with current machines. Actually, they are quite clunky in some ways by today's standards, where we're used to, I'm going to sort of let the cat out of the bag, where we're used to sort of on-demand system services in cloud, in that the hardware security modules or crypto modules were traditionally actually standalone devices that were hidden in a data center and required physical access. Over time, we've realized that you need to remotely manage such devices in lights out environments. And, that's to deal with patching them or in case of any sort of vulnerabilities or to update them. It's really expensive to get out to a data center to do this operation. So the idea of remote management, or actually remote card presentation, is something that hardware security modules support. If we go into the next slide. And this one's a big one. So this is what David picked up on today, or in his introduction. We're here to talk about compliance. And as you can see, I spend a lot of my time collecting badges. So from common criteria to FIPS 140-3, but there are also other ones. So you have regional ones. There's the CSA Knights scheme. There's ICP Brazil, and then slightly what I would term more exotic ones. They might not be something that we're all familiar with, but in some instances we actually have to have side channel mitigations or prove that we mitigate against side channels, or and actually pay for some licenses on the back of that, and that's what that DPA countermeasures lock is. And then with the BSI, there's various types of certs that you can go for, but specifically for random numbers, we have to get the AIS 31 cert, where they specifically test your random number itself. So what I'm drawing out here is that there's different, there's quite a lot of badges or a lot of certs or compliances steps that we have to go through, and there are some specialist areas. And let's just hold that thought. So if we go into the next slide.
just before we do, Pally, just for everyone's clarification, there's BSI here in the room today, British Standards Institution, and BSI, Bundesamt für Sicherheit in der Informationstechnik, which is something very different organisation. So it's just in case there was confusion, BSI, the German organisation there, focusing on information security.
Thank you, Dave.
Just so I clarify.
No, that's fine. That's perfectly all right. So here's where my story starts, and it's I'll sort of bring a little color to our lives. The picture on the left is actually what our internet looked like, probably in the 70s, around 73, where there were 45 nodes, all connecting academic institutes together. The picture on the right is one was created by the Internet Mapping project by a chap called Bill Cheswick and his team. And that's actually an image from 2000, the year 2000, and that's the result of ICMP pings and trace routes. And what it's showing is all these little tendrils, and the endpoints actually signify workstations, or basically the IP addresses that are at the ends of the internet, or as it were now. Roll on of 20 more years, and we've moved from IPv4 to IPv6. So whereas at some point you would have looked at those endpoints and thought they were, you know that they're workstations and computers, and maybe around that time I was probably playing with a Pentium computer. Right now, those little endpoints would be a baby alarm, or your toaster, or your fridge, or even your car. So you can just imagine how that landscape has grown. And that's, again, sort of underlying the comments on we require to have trust in something, and we should be able to operate safely in such an environment. So if we go to the next slide. So how do we get to this massive growth? And it's not purely based on the creation of physical devices. The thing that's driven the scale is actually the idea of virtualization. So we could actually create virtual systems. So you have network processing power and storage. All of those are created virtually. And more and more people are recognizing that there are huge efficiencies in cloud. You can auto-scale systems, the whole elastic piece around whether I can use things on demand and use more or less as I need is really attractive and cost effective. So there is the idea that we now move away from treating our servers and our IT systems as pets that we care about very carefully, to commodities, to cattle. And that's quite it's not my analogy, it's something that's been out, that talked about. So in the IT world, or the DevOps world, as it were. And then we've noticed that the growth of hyperscalers, so people like Google, AWS, Azure, etc., and these they're actually growing larger, huger, and they provide this massive capability to provide literally everything. So they're a one-stop shop for data services, tools, and they provide you with this huge amount of choice. The main thing here is actually the main message from this slide is actually is cloud first is definitely emerging as a default approach. It's something that we have to keep into mind. And so with that, we can roll on to the next slide, please. There are also more drivers for change, more recent drivers for change. So we've seen how we're now, more of us are working remotely, with COVID-19 in the last couple of years. We're also seeing challenges around actually building hardware. So chip shortages and supply chain shortages cause us some angst with regards to building systems. And then we're also all impacted by socio-economic factors, the wars and recessions and the impacts of that. So the world is changing, we have to adapt. And then there's the idea that we have more regulated systems and perhaps the new kids on the block that are less regulated, but might need to come into that fold where they can be trusted. And so although appears that there is a less need for traditional security, I think there is a requirement for some assurance. And to my mind, or my opinion, we can discuss that later, is certification is one way to do that. So if we go to the next slide, please. So, where does the HSM fit into all of this? And this is actually a snapshot. It's a slide that I had in 2019. So quite a few years back. And what was I talking about? It was like thinking about widening the applicability to support new market use cases. Within that, you've got automotive, fintech, IoT, etc. Greater, wider certification requirements to support those. And then on the right, we were trying to make it easier and more efficient for customers to deploy and integrate with the HSMs. And on that, there's a theme around as a service, or running things in cloud, as it were, and providing simpler access through REST APIs. So if we move on to the next slide. So that actually shows that things haven't changed in the, from a few years ago. This one's a really interesting slide in that it actually shows that what are the challenges we face. When we shift to, or we're trying to migrate to cloud-based systems, not all systems are built the same. So this is actually a taxonomy, or actually a schematic of the different types of virtualization systems out there, or actually tracks back from 1950s when they were starting to develop virtual systems, right from multi-programming to capabilities that did privilege separation, to the virtual VMwares as we know them that required some hardware support, right to the place where you actually carve up the operating system and now you can have lightweight containers. And towards the very right, you have mixtures of both. So you've got unikernel type systems, which actually are containers that reside in virtual machines. So you're trying to fix the problem to do with isolation as well as performance. And somewhere in there, you see a nod to Kubernetes, which is an orchestration system. And that's actually looking at how you can deploy, manage, and control sort of these instances. And it's thousands of instances that you're having to work with. So if we go, so that's one challenge, is that we've got huge amounts of virtualization choice. Going to the next slide. So this is not my kitchen or bathroom tiling, but it's actually the number of, or shows a big picture of different types of applications. So I'm kind of looking at the top layer where we actually can build systems in cloud, and the choice is endless. So if I were to pick up a storage device, a auditing or a security monitoring component, or some key management, or even orchestration type system, there's so much choice to pick from. And that, although that's fantastic, we get into a situation where we have to configure systems based on this. And how do we make sure that that is consistent and secure is one of the headaches that we face nowadays. So if we go on to the last challenge, the set of challenge, and this is, sorry, it's got a few clicks through it. Maybe we can just go through all of them. Yeah, that's it. So this is now looking at the orchestration level, the top level, where you're actually saying, we've got multiple clouds or different types of cloud instances out there, but each one of them have their set of threats. And this is actually a nod to the Lockheed Martin sort of kill chain, or sort of attack matrix as we see them now. And essentially what we're looking at is how an adversary will come into a system, try and get a foothold into the environment and continue to exploit it. As you can see, there's each one of those little boxes represents a threat or potentially a vulnerability that can be exploited. And that's just at the very high level of the system. We're not talking about lower level hardware. We're not talking about some of the configuration type challenges that allow us to bring both hardware and software together and how user applications are built. This one's just specifically just talks about Kubernetes. So if we go on to the next slide. So I've now summarized that. To summarize very quickly, we've looked at 3 areas where I've got challenge. One is on the platforms or the virtualization systems. The next one is the great amount of choice and how do I build a system based on all those different pieces of Lego that are even different shapes and probably provide different functions. And finally, we looked at, I suppose, finally, we looked at the different threats in such environments. But we now are in this place where there are challenges or opportunities as we see them. Again, that word trust comes up. So here, one of the main things we hear from cloud service providers is the fact that they try and have some form of plausible deniability. They say we cannot see your crypto keys, we do not operate with your crypto keys. It's led to different approaches where you bring your own key, you hold your own key. So users, you are running your workload or on someone else's computer and you have to trust them is the concern here. There's also concerns around confidentiality. And the architectures have to be balanced. So we're looking at implementing something that's performant but secure at the same time. One of the things that crypto vendors or creators of crypto modules have to worry about is actually some of that technology underneath. So the virtualization technology is leaky. So sandboxes and containers are actually quite leaky devices. And if you look at or review the paper from Alison Randall, where there's that wonderful taxonomy of virtualization, should actually go a little harder on that and say such technologies are probably inadequate to protect against the current, the microarchitectural attacks that we're seeing now. So, the Spectre and the meltdowns that we've heard of. And we might need to rethink some of the architectures in order to get better security. We're also now dealing with a different security model where you move from a system that is on-premise and is controlled quite carefully to one that's actually driven by chaos principles, where you bring things up and you shoot them down and literally do that instantaneously. It allows you to do things a lot more quickly. You can patch much more faster, but versions change very, at an instant, and that is a challenge, especially when you're thinking about some of the compliance. How do you certify a thing that moves so fast? So again, what I pointed out to is actually within cloud, because you've got all these choice and you're building up systems with lots of different components, you're now having to deal with systems of systems. You are dependent on many moving parts. So your logging and monitoring application is written by a different vendor. Your admission controls are written by a different vendor. Bringing all those together is quite a challenge. So where do you draw your security boundary, as it were? Where do you draw your compliance boundary? It is going to be quite a trick. And then there's the other side around supply chain assurance and making sure that you are building and sourcing your components in the right way. I don't need to remind us of things like the SolarWinds type attacks, which was actually an attack on the build system itself. And rather than someone sourcing or poisoning the actual repository where the software came from. So if we go on to the next slide. So this is one view, and it's quite a modernist sort of a view as like looking to the future and being way out there, saying actually we need to worry about some kind of unified control plane that allows you to secure systems across the different clouds, as it were, that will allow you to manage policy, that will allow you to do security in a way that is consistent and traceable and transparent. And this is an idea, but I have a feeling that we might also need to consider such an idea for our certification purposes. And with that, I would say, if we can go to the next slide, that's basically saying thank you for listening. I hope it's kind of given us a little bit of food for thought, and I'm looking forward to our panel discussion. So back to you, David.
Thank you, Pali, and that's certainly food for thought. I'm completely stuffed after eating that lot. A lot to take in there. But I think it's so important that when we looking at specific detail around a certification scheme and application around one particular element of what is the ecosystem that fits in, and what are the problems that industry is trying to solve. For me, there are a few key takeaways there. Number one, we started there talking about the proliferation of the kind of endpoint and devices, but then I think very quickly we can see that virtualization environment and the massive rise in cloud and the multitude of solutions, together with the fact that boundary, where does that security boundary really lie, really important there as well. And again, I think your point there around the digital supply chain, very important point I'm seeing in general for digital trust. Really like your idea. I can see massively the benefits in that single unified control plane going forward, and that I think would help things massively, and that's got to be a longer term aim. But then we'll come back down to where we are now, and while that's all stewing in everyone's minds, thinking about that incredible complexity around that wider ecosystem, I'm going to invite Miguel to join me up here on the stage, the virtual stage, and just talk us through some of the latest in what's happening around 19790, the standard itself. Make yourself comfortable down there. I think we've had a few issues with microphones, so we're going to sit around the laptop for a cozy little chat.
Okay.
Over to you.
Well, let me.
Do you want to drive it? There's the control.
That's too modern for me. I have to speak close to the laptop. Please, the remote audience, if I tend to lower my voice as I speak, so please just let me know. Thanks. First of all, thank you, David, for inviting me here.
I've got to say, Miguel is literally off the plane.
Oh, yeah.
Just arrived straight here from Europe, so really grateful for you coming all this way. Thank you so much.
It's my pleasure. I had fun this weekend, losing flights and reconnecting and things like that. But I was lucky to arrive just in time for this lovely workshop we have. Let me introduce myself. I'm the convener of ISO IEC JTC1, Joint Technical Committee 1, Subcommittee 27, Working Group 3, which is the working group which is to blame for this standard. So I really enjoy, and I'll have a lot of fun coordinating the development of these standards and convening these experts from all over the world. We just happened to have our last meeting 2 weeks ago, so I will give you a very highlight glimpse of the standards we developed in this area, and I will provide you very latest status of where we are in the maintenance of 19790. Yes, this is too modern for me.
Go back to the page down, I think. Try.
Which one is forward?
Good one.
Okay. Well, I will introduce the core standard 19790, but that full document cannot be applied by itself. So we have developed a full ecosystem of companion standards. So we'll talk about 24759, where we put all the standards, the status today, and then I will provide you an overview of the rest of the standards that we also developed. So 19790, and whenever we develop a standard, we always have to answer the question, is there any market need? Is there any user need? And this question and answer was discussed many years ago, and there is a need to have secure cryptographic modules. At the end of the day, there is no secure protocol without underlying secure cryptography. There is no secure cryptography without proper and properly implemented algorithms, without high quality random number generators. And this standard provides that. This standard provides well, the best agreement we can have at the international level on secure cryptographic modules. And it does so because nobody wants to spend more money than required. Nobody wants to put more, more resources than required. So, and there is no absolute security. There is no absolute cybersecurity. So the standard itself recognizes 4 levels of security. Because for some use cases, you can be done happily with a lower level module. For other demanding cases, you may need the most secure thing that you can buy. And in these 4 levels of security, the standard specifies requirements. And these are functional requirements, these are design requirements, these are operational requirements. It's the full analysis and the risk assessment of what can be wrong in a module, and then we have requirements, security requirements for that not to happen. So this is the core standard, which is requirements for a vendor to read the standard, understand how they need to design a secure module, and then we can test conformity against this thing. And conformity is mostly done with a companion standard 24759, which for each of the requirements specifies the tests that the independent lab has to perform, how to validate each of the requirements, and that is in 24759. So the idea here is that the assurance is to be provided by third parties. We love the vendors, they do a very good job, but in the area of assuring things, whenever you want to have assurance, third-party attestation, third-party testing, third-party certification is very important. So this standard has been designed to be applied by third parties, the labs. So in this, another one, 24759, we tell the lab what tests they have to do. And the tests are being designed very specifically. They are very objective tests. There is a great effort to reduce subjectivities. The tests are really straightforward, and they are very demanding. And in the standard, there are no reasons. It's only do this. If this is the pass-fail criteria. If it doesn't pass, out. But it doesn't provide the rationale. The rationale has been behind in the thinking about that. But it makes this standard very straightforward to be tested. So compliance is easily determined, or non-compliance. So as I told you, we had a meeting some weeks ago, and this is where we are. So let me go back to the origin of time. This standard, as any other ISO standard, we get new work item proposals. And new work item proposals can be received from experts at the meeting. They can be received from national bodies or from external parties. So some years ago, we received as an input a document from the US administration called FIPS 140/2. Okay, and this was a federal publication, but was the basis for the certification scheme that the US and Canada had put in place. But it is only a governmental document. It's not a standard, as we know, we understand. So they submitted it to ISO, and we launched a project And based on this input, we published 19790 in 2006. Every 4 years, we discuss what to do with the standards. Shall we review it? Shall we withdraw it? Shall we keep it as it is? So in 2012, I mean, that means we started 2 years before, but in 2012, we published a revision of this standard. Okay, it was quite a move, it was quite a change, it was quite modern, I would say. 3 years later, we did some editorial changes, we made some mistakes. We can do that through something called technical corrigenda. But last year, we decided to review the standard again because we have users, certification schemes are using that. Those are governmental certification schemes, those are private certification schemes, and they come back to us saying, hey, this can be better, this can be improved, this is wrong, whatever, blah, blah, blah. So we initiate what we call a revision process, and we start again from scratch. We don't start from zero because we have as starting point the previous version. So the previous version becomes the first working draft. So now we are in the 4th working draft. And the expectation is that we will publish and close this revision, and this is nice, in exactly 2 years from now. This is the date on the ISO portal, 17th of October 2024. Okay, so we happened just to meet 2 years before. Not 1 day more, not 1 day less. Okay. So in 2 years from now, the team of editors that are working now, and this is a very open and international team. We have editors from Canada, Korea, France, and Great Britain. Those are the experts that are now doing the editing of the revision of this standard. So hopefully we will do that in 2 years from now. So what are we changing? What are we modifying? Well, many things, many small details, because in cryptography and cryptography modules, every little detail has a lot of consequences, a lot of impact. So two weeks ago, we closed 2 weeks of discussion because we had received, I think, 400 comments or more than 400, and they were discussing security parameters, critical security parameters dealing with manufacturing of a device, attestation of the status, security status of the module, the operational environment which is modifiable, how to establish entry and exit security parameters, serialization requirements, physical security requirements, and definitive state model requirements. Okay, parts of it. So, I mean, every page of the standard is being revised. We are receiving hundreds of comments, and we are doing a very intense but really exciting. You may think that development standards is anything but exciting, but I can tell you it is, because we so many inputs. All the experts sit together, and they have to come to an agreed, internationally approved decision based on consensus. So this is where we are. So in 2 years from now, we have to have a new revision of the standard. Okay, so that's the main standard, the core standard. Let me talk about the rest of the family. How to verify the correctness of the crypto algorithm is very important. It's a precondition. It has to do digital signature, it has to be done right. The second problem is if it's secure, how to do that. But the first thing is to verify it's properly done. So we have another standard providing guidelines on how to test these requirements. Sorry, these crypto implementations, crypto algorithms. We have a brother working group 2, with the ISO responsible for standardizing crypto algorithms. So whenever they issue a new algorithm, we have to check whether in our standard we fit with the protocol to verify that thing. And we also have another standard to analyze the entropy of random bit generators, because cryptography is I would say, mathematicians live in a very nice world. It's ideal. And they say, let R be a random number. and then we come the computer engineers, and we ruin the dream, because there are no random things in a deterministic machine. So we have to figure out how to produce sufficiently apparently random numbers or random bit. So we have a standard on how to test the entropy, the apparent entity of random bit generators. The module has to be secure, so it has to withstand attacks. And we distinguish two types of attacks. Physical, you try to open it, you try to break it, you have invasive attacks, but we also distinguish what we call non-invasive attacks. So for physical security, we have another document that provides all the principles, practices on how to defend against physical attacks. We don't provide the best practices on how to attack, but on how to defend. But the interested reader may take whichever sense of the same direction. And we also have standards for the non-invasive attacks. These are terrible things, because you don't need to touch the module. You only need to observe things like electromagnetic emissions, like power consumption. And based on those observations, many years ago, we had statistical processes that were able to obtain the key, because you were able to characterize the consumption of the emanation on the given unknown algorithm. Nowadays, attackers are using kind of advanced techniques with templates, artificial intelligence, and things like that. So without touching the module, if I can connect to the power supply, if I can put an antenna close by, I could get the key. So we have here another standard on how to test the module, so we can be pretty much sure that it will not be weak. It will have no vulnerabilities in that type of tests. And this may start looking to you complex, and it is. It is very complex. Random bit generators, entropy analysis, non-invasive attacks. These things require technical competence. But I told at the beginning that we are assuming that this will be done by third parties, by labs. So we also have standards to guarantee and control how these third parties have to manage and how to achieve the given technical competence. Okay. In the conformity assessment world, there are standards very well known, 17025, are applied for by every test lab in the world for water, for everything. But we provide the specifics on this field of application to supplement 17025 to qualify the testers and the labs themselves. And finally, all these standards are, I think, mostly oriented to the design, development, production phases of the life cycle of the module. But the module will be used by someone. Somebody is going to buy and use the module. So we cannot forget the full life cycle of the module. So we have a technical specification providing guidance to the module user, so they can understand the security policy model, they can understand the technical documentation in order to operate the module in a manner consistent with the particular security problem and the risk scenario. So, so we come to what I call the family picture, which is not just the standard that was the heading of this workshop, but the full family of standards that build the ecosystem and that allows to set up certification schemes, as you can see, with many technical aspects, very well regulated and agreed at international level. Okay. So many thanks. I don't know if I've spoken too much.
No, that's fine. That's
okay.
Great, really interesting. First and biggest point for everybody, hopefully you can see the level of detail and global consensus and expertise that goes into shaping an ISO standard. So if there's one reason why using an ISO standard makes sense, is you know you are working with globally accepted best practice. I think this is a really, really key point when looking at it from a national government perspective, why reinvent the wheel if the heart of what you're concerned about that product has been assessed through compliance with an ISO standard? A couple of questions though, just to clarify for everyone. So 19790 itself looks at the security techniques, but doesn't actually test the efficacy of the algorithms. So you're saying then there's a separate test for algorithms within 19790. It's more about establishing that correct algorithms are present rather than the efficacy of the algorithms themselves.
Okay. When looking at the security of a module, when you want to use a cryptographic module, there are concepts that last over time. And these concepts that last over time are in 19790. I want the module to have data input output separated from control input output separated. I want the module to stop providing services when the crypto officer is changing keys, blah, 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 blah. So there are concepts that are completely not independent for the specific crypto algorithms. Okay. So the requirements for the security of a module go into 19790. Now this module is going to run a given set of crypto algorithms, and these crypto algorithms are the ones who have the shortest lifespan because they become vulnerable with the progress of technology. So algorithm that was nice to be used, was suitable to be used 10 years ago, may not be suitable now. So the standard has been designed with that flexibility in mind. So the list of approved algorithms is not provided by the standard. It's going to be provided by the certification scheme or even by the end user. Because it depends on my scenario, it depends on my application, it depends on my vertical, whatever. Because if I'm in banking sector, we may have some standards, some crypto algorithms that we use. We have to use it for interoperability. If I am automotive, the same thing. So the algorithms may be different. If I am processing governmental information, my government may have some algorithms different from the other. But the standard doesn't care because it's been designed modular in that sense. So if we see the different certification bodies that apply this standard, maybe they may be using different algorithms, but the standard doesn't care. In the crypto conformity testing, what we do is to specify the type of protocols according to the underlying mathematical basis of the algorithm. If it's a symmetric thing, so the protocol goes with non-vector attacks. So those are the mathematics. So we don't even detail what algorithms. So all these set of standards have been designed to be crypto agnostic for these two reasons. First of all, because the crypto changes because of vulnerabilities, or because the crypto changes because of the environment.
Yeah, so as you said, either sector or different governments might specify different algorithms. So just to clarify then, the standard itself really looks at the module design, and then you're then assessing that the correct set of algorithms are in there. Yeah. As assumed in a scheme, you would be assessing, okay, does it have these algorithms present? But they would be algorithms that are pre-tested, pre-agreed, authorized algorithms.
They have to be pre-analyzed and pre-authorized by whoever is going to use the model.
Great. Thank you for the clarification. I think that's an important point when we start to look at how we can have a common scheme and looking at what are the key areas of national difference. Thank you. Right, so we're just going to go on. In fact, do you want to just, if you mind just taking the chair, one chair along here, so I'll ask you to play musical chairs here for a second. And what we're going to do now, there we go. So we're now going to start a bit of a panel discussion. So if all our panelists could join us here, and what I'm going to do probably just before we start the main discussion, I'm just going to show one slide again, which is this one that Pally showed earlier to really set the scene here. So this is one particular manufacturer and the kind of certifications they have to go through. So Pally, before we just do the full, get the full panel session together, if I can just say from your perspective, obviously I don't want to be leading the witness, as they say here, but it does seem to appear that a common approach would make sense for you, were it to simplify and reduce the number of complete certifications you had to go through.
Yeah, absolutely. I love what Miguel was alluding to with the modular approach or modular standard. I, as a vendor, would like to be able to produce and provide modular evidence. And maybe that's, something that we can discuss now, because it's having to go through each one of these specific standards and sort of deal with the differences and the intricacies is painful. It also means a lot of effort on our part with regards to actually collecting different sets of evidence. So if I was able to produce sets of evidence that were, essentially modular or something that was reusable, that would be fantastic. And then, yes, we can tailor to individual schemes as we need it. And again, Miguel talked about a process that allows you to do that. We've seen that with the algorithms. It certainly will be cost effective. And one of the biggest things that I've got as a challenge is when I go to my engineering teams, we're all running, many of us actually run the agile process. And what that means is that we're running as fast as we can. Engineering picks up on developments that they like to do, but they're very light on documentation or providing evidence. So that's always a challenge. It's really difficult. And I think, if I would ask anyone in the room where their big challenge was, it would be providing evidence is the hard part for me. Yeah. So thanks.
Thank you. So on that note, really kind of sets the scene, I think, for a kind of wider discussion here on what can we do to facilitate it from a manufacturer's perspective, but understanding that the needs of governments, the needs of different sectors are going to mean that there is not going to be a one size fits all here. So I'm just going to fiddle around with the tech here for a second. Miguel, I'll go back to you. Obviously, you've been working with the standard for this flexibility in mind as a key point. What do you see as the key areas that different certification schemes, different government schemes look at? So we've looked at, obviously, the algorithms themselves. What do you see as the other blockers or other areas we need to consider if we were looking at a common framework? I mean, I can see there's the requirements in documentation, for instance, or tools. What would you say the key ones are?
If we are talking about different 19797 schemes, because the picture you had is the standards, not just. So the question is about different 197.
Purely 19790, yes.
Okay. Well, the thing is, nowadays they are pretty much well coordinated. I mean, in this the maintenance process, the more than 400 comments, most of them come from the schemes that are applying the standard.
Okay, now that's a really.
And the thing is, they find different things, but when these comments come in,
right,
the outcome is an agreed solution.
Yeah.
So
absolutely.
by taking part into the maintenance of the standard, the schemes are self-synchronizing themselves.
Okay.
We normally are criticized by the time we take to develop or to raise a standard.
Yeah.
But the thing is, we are buying international consensus and quality with time.
Yeah.
So.
And what you were just saying there, the updates, looking at some of the updates coming to the next version, all of that again says to me, this is best practice in one area here, and surely following that is the way that everyone should look at. So speaking about everyone, at this point, I will then see if we can get the rest of our guests to join. Is Mr. Chang from SGS with us today? Oh, sorry. Would you mind joining us up here as well? So thank you so much for joining. If I can ask, because of some issues with the tech, that we all budge up and have a cozy little seat over here. We just budge up over here. if we just kind of come over this way a little bit, I'm sorry, but we're limited to this microphone at the moment. And then online we have Jose Emilio from DECRA.
Hello,
And
hello.
Hi,
Good
Jose, how are you doing? Good
Very
to see
good,
you again.
very good. Good
And we have
afternoon.
Sandra and Davy from CIRMA.
Hello, how are you?
Hi.
Nice to meeting you all.
Hi, so can I ask first of all that we just do a quick introduction around the room? If I can start with you and just say who you are and where you're from.
So I'm Kaifan. Kaifan Sham from SGS Fireside. Last year we were acquired by SGS, so we became SGS Fireside. But before that, we known each other for a long time. I worked in the common criteria world on the high assurance additional security evaluation type of work. Now we're also looking into the new IoT related connected device related security. Also looking into the cryptographic module testing evaluation of different countries. So it's an honor to be here to participate in the panel and the event.
Thank you so much. Thank you for joining. And Jose Emilio, if I go over to you next.
Hello, morning. My name is Jose Emilio Rico, and I'm the director of the cybersecurity division of DECRA Testing and Certification. DECRA is a testing, inspection, and certification company, and of course, we have cybersecurity services as part of the portfolio. The cybersecurity division has two places, two locations. We have two labs. One is in Madrid, and this lab is the one that performs, let's say, the accreditation work, because we are accredited in common criteria, and also we are accredited for conformity testing of cryptographic models for FIPS 140-3 and also ISO 19790. We also have a conformity assessment body for ADAS-EU regulation, and also accredited for NESA's GSMA of network product evaluation. We also have a lab in Malaga. This lab is mainly dedicated to penetration testing for IoT consumer, automotive devices, and also functional testing in industrial framework with 62443. And also we are authorized for IXT Alliance, Alexa, voice services, CTI, GSMA.
Thank you, Jose Emilio. We have a laboratory in Hemel Hempstead near London. I'd much rather we had a laboratory in Malaga, much nicer place to be, very envious. Thank you. And now, Sandra, if you and Davy would introduce yourselves from CIRMA as well.
Yeah, hi everybody. So my name is Sandra Garcia. I'm the business line manager for FIPS and PCI evaluations within the IT security lab itself, which is CIRMA Safety and Security in France mainly. And this means that I coordinate teams on the PCI and FIPS business line, and as well as the relation with these schemes. Very excited to participate in the meeting with you. And regarding the lab where I work for, we have over 20 years of experience as an independent lab, performing assessments or like common criteria and private schemes for banking like Invico, Visa, MasterCard, CC for IoT, and others for transport, for instance.
Thank you. So as you can see, everybody, we've got some real in-depth experts with us here to talk this through. So getting straight to the heart of the matter, if we were looking to have a common approach for those countries who have schemes based around 19790, we've heard already that algorithms, it should be straightforward to have a common approach to the module itself, and then look at how particular algorithms could be embodied for different countries. What are the other issues as your organizations involved with the testing right now? If I maybe go to you, Mr. Chan, first of all, what do you see then as, were this to be a common approach, what are the other key areas that would need to be looked at to address the kind of national differences when you're looking at certification for, say, Japan or Korea compared to Singapore or China, for instance?
So we just started with the 19790 type of services. And we just acquired systems.
Unfortunately, we're trying a microphone, but there was tremendous echo. So I will see whether we can get away with it. Just want to try it with the mic. Oh, there we go. It works.
So, like I mentioned, SGS price.
Some of us have lost audio, David.
Still echoing, or I can go on?
Okay. So try again. Keep going on. I think I've now put the audio back on. Please continue.
Okay, so I'm personally not so familiar with all the countries that have ISO 19790 related standards, but during the process of developing this kind of service with FIPS, and also what we're doing in China is to develop OSCAR related services. OSCAR is basically a kind of fixed standard for Chinese algorithms. And we already see a lot of different approach that is really have their national flavors. I don't know if there are any ways to overbridging that. And today, really, I was really interested in Miguel's presentation on the comparison. What we hope to achieve is to use the 19790 as a proof for our customers that their product or cryptographic modules also satisfy the FIPS 140-3. Due to any type of reason, technical reason, political reasons, and that's what we want to achieve. But for the in-depth comparison, maybe I think Miguel knows much more than me.
Okay, thank you. Well, maybe we'll go over to Jose Emilio. I know he's been working in this area more extensively. And Jose, from your perspective then, when we're looking at the specific requirements around, say, FIPS 140-3, what is there that you would see as the challenges, or what we would need to look at if we were to have a common approach based around purely the 19790 standard?
Yeah, thank you. So fully relying in Miguel's presentation, and to think that we have cryptography in all the products as a core for security protection. Going a little bit outside the design of a cryptographic model, I think we have the scenario that we have really is not only to have these cryptographic models as they are thought in 19790 or FIPS 140-3, but also we have products that they are not in fact security products. They are ICT products with crypto, and this crypto is tested in a different way. Security requirements or requirements for the design are fully different, accessing the crypto, and they are understood in a different way that the cryptographic model is understood or is defined in FIPS 140-3 and 19790. In addition, we have specific cryptographic models that fully depends on the verticals or the use cases we have for them. HSMs are not the same if we have an HSM for ADAS, or if we have an HSM for automotive, embedded boarded in an automotive, in a car, because the protocols are different. So finally, there's not only to have a common consensus on the standard, but also how to use them and how to test. We can start from thinking about the algorithms. What are the algorithms, the approved algorithms? This is the reason why the 19790 is agnostic of that, and each of the schemes have their own perception on that, but also we have the tools. What happened with the tools, and what happened with the full possibility of recognition of already certified or validated algorithms. We have tools in the NIST, we have CAVP, validation systems, that these validation systems and tools are not recognized, for example, in the Spanish certification body. And what happened with this is the vendor, as Palisade, the vendor need to apply and certificate the product in the different certification bodies and schemes. And because of this, we will not be able to reuse as a lab, for example, a testing performed in the CABP and in the Spanish scheme, because we need to test them using the VOTAM tool and other different methodologies. So my perception then, there's a need for first the harmonization of standards in respect to the standards applicable for algorithms. Then we need harmonization of testing methodology, if this is possible. And we have, for sure, algorithms. We have the core of the crypto, which is the entropy sources and the deterministic random numbers, for which we have several approaches, very known approaches in ISO, in the NIST special publication. We have also the German IS 20 and 35, IS 31, sorry. And finally, very important for me, a consensus for also what kind of transitioning we have for the algorithms, availability of algorithms, suitability of algorithms, key lengths, and all of these things.
So we discussed algorithms before. A very important point you've raised there. Well, first of all, it was looking at the wide range of products. Maybe we've also got to look at here what's in scope, what we can manage through this process, and what isn't. And obviously there are some where, we may be talking, I think, Pali, to your point earlier, that there may be some of the more basic products in a different kind of a sector, which it just might not apply to. So we've got to find really the boundary then of what products and applications will be within scope. We've mentioned algorithms. And the other really important point you mentioned there was around the tools. So even if we're testing to the same standard, we're algorithm agnostic and we're using the test guidance, if there are different government or specified requirements for tools, that still doesn't help, because you still need to have the test done with those individual tools. So building some consensus around tools sounds to me like a really, really key point in order to have that common framework, because without that common approach there at the tool level, you're still having to repeat. I don't know if, Miguel, you have a comment on that.
Yes, and is that we have standards for the tools. However, some schemes are not probably aware of that, and instead of requiring that this tool be the standard, they just adopt their tool, and that's the only thing they want to see. So, from my point of view, from the ISO point of view, we have and we are doing an effort to explain what we do, because not always is well known. We are running an annual conference on 19790. There is one run in the US. I am trying to go that conference in Europe, precisely to explain the full roadmap of the standards we have. Because we have standards for the testing of algorithms, we have the tool, we have the standards for the non-invasive testing tools. So we're doing a lot of effort precisely to do that.
Right. So again, why choose something yourself when there is global, international best practice proven by consensus?
Don't ask me.
Exactly. I mean, as a rhetorical question.
Maybe because it's quicker, or the thing you have there, you have invested some money in developing a scheme reference tool, and then, there is no need to work on mutual recognition. So if you're only looking to your internal stuff, you do it as quick as possible and you don't bother with big standards. If you are confronted with the need to recognize your neighborhood certificate, then you will come to see the standards.
Okay, so it definitely looks like there's an action here on the awareness then around the availability of standards, common best practice for tools, as well as just for the general test methodology.
I think the specificity or requirements on the crypto side has somehow slowed down the full picture or the mutual recognition of the full picture.
Yeah.
And that's a pity because, as you said, it's completely modular, and we may not even agree on the same algorithm, but we could agree on the rest of it.
Yeah.
And the vendor who designs and develops the module very secure and does it in a manner that they can change, remove one or the other, can be crypto agnostic, can test the module for both markets, change the crypto, and there we go.
Yeah.
So, but this is a process that is starting to be seen.
Yeah. So I think from the algorithm side, I think that has been relatively clear and can clearly see a way forward. I think on the tools side, it's going to be more complex, but with something, again, I think it's an awareness case here, really, to make sure that everyone, all the national schemes, are aware of the fact that these standards are there.
It's not only the schemes, but also the tool vendors.
Yeah, right. Okay, it's a very good point.
So, for example, one tool vendor that develops non-invasive attack tools is heavily involved in the design of the standard because of
Okay.
the alignment of the business. But that's absolutely legitimate in this development. So I mean, this is a very small market, I would say. As of now, it may explode, I don't know, but we are transitioning from immature, handcrafted solutions to a global big problem.
Yeah.
And we have to professionalize, and we have to make much more. I mean, we have to increase the quality and security.
So again, I think that was really put well with a couple of those presentations today, looking at the size of the demand in the market and the need for something that isn't this perfectly crafted and handmade crafted kind of solution. So at this point, if I could go over to Sandra and the CERMA team here, one of the other issues in order to hit scale really would be to consider how ongoing updates can be managed when in particular you certify one entity, and as we've heard from Pali today, that can change in an instant. Just wondering really from the CERMA team, how much you see products, this kind of product actually changes, and currently, how is that managed? If you were, say, looking at FIPS, I know you guys are working, I think, with 140-2 mainly at the moment, but then how is that managed right now? Because, you know, it's nothing new that the products are going to change. So how is that managed within the current scheme? How often do clients come to you then for recertification, or how is that managed with NIST? Are there any lessons we could learn from that when looking at how to recommend a common approach going forward?
Well, there are two different things. What happens when a CB is found, for instance, and then the developer, the vendor, has to implement a quick patch, a 0-day patch. And this is for PCI, for FIPS is mostly essentially the same. So they have to patch the vulnerability and then undergo evaluation through a delta for PCI, and in FIPS also. I do not see complications on that. It's more complicated from the point of view of the developer, I think, than for the lab, because he's the one that has to do things fast. And
so in terms of developing the changes, then that's fine. And then is there, in order to maintain compliance, what are you looking to see in terms of evidence then of how that change has impacted the whole design, or whether it's a limited, you can validate a more limited scope retest?
Yes. So in principle, we look at the changes. So it's as usual in all the labs, we ask for the Delta document, we see at the particular changes, we look at the code, but we also have to look at the periphery of these changes to assure that nothing else has changed. And this takes some time to.
Right. So when we're looking at change, again, I'll just try and go back to you on this one as well. So again, you must have seen similar things. What's your experience then in the lab of how often these kind of products change or updated, and what's the impact then on the vendor in terms of, you know, they're coming to you saying, okay, tell me the scope of what needs to be retested?
I think that's becoming a bigger problem nowadays with the connected device, because they have to be updated.
Yeah.
Basically weekly or monthly. And it's also an extended life cycle for things like automotive. Before they just ship out the car, and never have to worry about it. But now they have to keep updating the car. So the speed of recertification or the need of recertification is always a big issue, and also biggest problem with things like common criteria, because the procedure is simply too complex and too long for this type of thing. Of course, you have things like flow remediation to make sure you have a good update process, but it's not really what the customers or the developers are looking for. So that's a big challenge now, and there's no straight answer except because whether you want a certified product that is not so secure, or you want an updated product that is not certified but more secure. There's always a discussion between us and the certification body on that. So I hope for STEM and SEO, we also can reach this type of agreement on what is the right pace and the procedure for update and recertification. And also one word about the tooling. I think to understand the scattered tools that we are using is also traditional, because traditionally each lab we develop our own tool so that we have full control, and that's required by the certification body, that you have full control on your testing tools. That's why you can see Bryce I have a tool, Riskio has a tool, Miguel has a tool, and everyone has their own tool. Of course, nowadays we see more commercialized tools, but then it won't be maybe regulated or just certified by the certification body for certain testing. That they will, one tool will be certified, and the next day the other tools they also want to be certified, because simply we're using different tools that traditionally are there, or we don't want to be wanted to be a bottleneck, so that we cannot develop new modules ourselves, and we have to buy from our competitors. So that's, I think, the main reason of why we have so many tools that are used. Of course, we should find a way to deal with them. Just my view on the tools.
No, thank you. That's a really important point. So I know we're running quite late here. We're running a little over time after a slow start with a bit of technology issues. So what I'm going to do now is just pull together some of the key points here. So as Miguel said, the ISO 19790 standard, it now has input globally, global best practice. It's just going through yet another update. It seems to me to be common sense to have this as the center point for any certification scheme based on cryptographic modules. In order to have this common approach, we need to have flexibility in there, looking at particularly around the algorithms, but also we need to address two other key issues then. As the team at CERMA was saying, you know, these changes are happening all the time, and it's a pain for the manufacturers. Yes, you can there and looking at the scope of the change, but these changes are coming, and each time you need to retest and recertify. And as you were saying, now with, you know, over-the-air updates and just these regular changes coming through, that recertification isn't practical. So we need to consider an accepted method to allow more rapid certification. Then the tools side of it, now that was an interesting debate, because again, if we look at, certainly my experience is the number one thing that we have to do when evaluating a test is the test environment, and having a stable, repeatable, secure, trusted test environment. So different manufacturers have different tools, different vendors, different labs have different tools. And then we have the issue of the specifiers occasionally specifying the tool. So I think there's a big focus, I think, for moving forward here is getting that discussion around tools to the point where we can agree what is that balance between flexibility and then having something that we are not then having to recertify on different tool sets for, just for the sake of access to different markets. So maybe some standardization, well, again, the same, there's a standard there for it. So maybe let's pull that together and say, okay, we've got a standard here for those tools. And if those the test environments in the different labs can be demonstrated to be compliant with that, does that overcome the problem? Or if not, what is the challenge? My battery is running low. That seems to be a challenge, though I'm actually plugged in. Okay, that's also telling me that we're nearly at the end of the time as well. So I do apologize for running over, and particularly for the guys from CERMA just getting a comment in there at the end. But your comments, your input has been absolutely invaluable in looking at how we start to move forward. And what I wanted to do was look at really the key next steps. So I'm just, if you wouldn't mind helping, just switch it. I'm presuming, yes, okay, going. I'm presuming I'm plugged in, but it's not just switched on. So if I just come to the point of, let's go back to this again. If we're looking really at key next steps, I think we've seen quite clearly there's a need. There's a manufacturer saying, look, here's all these certifications I have to do. It isn't viable. We've seen the need for scale. We've seen this is already happening at scale, hyperscale. Therefore, the certification environment needs to reflect the demand, but still maintain that trust in that certification. So key next steps for BSI, we already released one white paper on this. So I think the next step for us is to look at the tools situation in particular. I think the whole of the algorithm validation will be quite a simple one to fix, but the tools and then a process for enabling quicker, more effective trust in updates. Those two things I think are fundamental to making sure that a new certification scheme addresses market needs. If I can just go round again and just really get the last comments. I mean, you've summed it up, to be honest, really well there in some of the challenges. What do you see as the opportunity here then, if we can get this common approach together, from the different, obviously the different markets that you're involved in right now?
So I'll start. So I think the most important thing is that we just started the work, and different labs might have different approaches, different results in the beginning, but then that's how a scheme is formed, and certification body will monitor and compare, just work together as a tight community. And I think phase 19790 is at the perfect point of clash of traditional security and the new type of security. So we joined SGS, we started to develop, but like consumer IoT, they have their own requirements, and that can be developed independently. But something like this, you are also trying to do the traditional things like side channel and all those kind of attack in a new way. And I think that will be a challenge that we need to work on.
That's another good point. So from you then, it's let's just start doing it. That's a very, very good point.
Yeah.
Thank you so much. Maybe I could go over to Sandra now as well. Any kind of final comments from you or where you think we should start?
I think we should start with having more meetings like this one, in which everyone can list, or we can list at least the main points from each of the different national schemes, or the problems we found, both as labs, vendor, and also the facilities that certificate finally the reports. So next step will be continue doing this kind of meetings and putting in common all our experiences. That's
Thank you.
There are many
Thank you, Sandra.
problems.
That makes perfect sense. So more dialogue between the stakeholder groups. And again, that's what BSI, that's what we're here to do. Jose Emilio, over to you. Any further comments or last points from your side?
I think that crypto finally is a transversal topic on all the technologies and all the schemes. So first, of course, continue to have this progress in the definition of standards. Finally, the scheme should be based in fully recognized standards. So the first one is progressing in the definition of the continuum of the maintenance of the standard. And I think that could be good if we can have some harmonization of implementation of some algorithms that finally it could be the same in some situations, but we have several standards, several RFCs, ICE versions, and try to harmonize them. It is a very good work. The thing that we are doing in Europe, according to the Cybersecurity Act, trying to define schemes for the certification of products. And in this sense, this harmonization of what we have addressed for certifying the crypto could be good, because as I mentioned, we don't only have cryptographic models, but also we have crypto in ICT products, and there's a it's fully different if we address the security product itself than other products that are implementing security through the crypto.
Yeah, absolutely. So again, it's keeping on top of that whole standards landscape, looking at things, looking at that wider environment, so in areas such as the EU Cybersecurity Act, and looking at that the wider group of not pure cryptographic modules itself, but those other products that are not pure. So looking at that wider environment. Okay, so that, if I then go on to Pali next, hopefully for you, this is music to your ears, hearing how the
I've lost audio, but I'm going to try and lip read.
it was the
David.
end of the final point for me on this really was going to be over to Miguel, but it looks like we've just lost the rest of the connection there. But the key points here I can see are moving forward with the next versions of white paper, and then carrying on this discussion with this team. Obviously, we've got the right people here from the development discussion. We've got some very experienced with the standard, others I know it's new to you, but you're bringing in a wider scope there of experience then around the edges of that as well, which I think is important. And Miguel, then, obviously, you as the convener of the working group, what do you see then as where we're going with this and what the next step should be?
I don't know. But we draft the standards and we publish them when there is a problem that needs to be harmonized. So to me, this type of discussions and meetings are fantastic, because we can see that the expansion of this need requires further harmonization. That means that when you discuss tools and the different labs, technical views on how tools should be, maybe our standard is not enough and it needs to be complemented or whatever. So the thing that I can offer is an open door, a red carpet. So the immediate needs or future needs that need to be harmonized between certification bodies can be standardized as soon as possible. Because that is what provides full information, transparency, and visibility to the end user. These two labs or these three certification schemes recognize each other because they have secret discussions or because all of them agree to comply with the same open documents.
Right.
I think it's a natural progression of this type of standards that started in a very small market, governmental oriented. They are now expanding internationally, and they are now expanding market-wise. And this expansion is bringing as well an increase of harmonization requirements.
Yeah.
That's music to the standardization body.
Great, that's good to hear. So thanks everyone in the room for staying with us here. I know you've got quite in-depth technically for quite a large portion of that, but this is a very complex subject. So thank you for staying with us. Apologies that we lost everybody right at the end there, but oh, we're back on. Brilliant. Okay, so even though you can't see me, hopefully you can hear us still for the end of this. And
Yep.
What's great for me is I can really see a clear way forward, I think, where BSI are looking to drive harmonization, best practice around ISO standards and bring really a quicker, more effective route to this vital technology to help secure that rapidly growing and very exciting digital future. So on that note, thank you so much, Miguel. Thank you so much, Mr. Chang. Thank you so much to the remote panelists too, and to the audience who hopefully stuck with us through that last glitch at the end there, and particularly you in the room. Thank you so much for your patience and attention too. And look out for more from this space, which will be another meeting where we will move this on, and an updated white paper from me, which I will get the input from all of you on, and thank you so much. Thanks everybody.